Hello, today we're going to do 5.6 from our Apex, the checkup. Get ready for our quiz. Let's warm up though from the 5.5 lesson you guys did probably yesterday, the day before. So we learned that if we have an inscribed angle, this angle ABC is inscribed, that angle measurement, which is what they're asking us for, is half of the intercepted arc. So angle A BC, that's not a B, is half of the intercepted arc. So angle ABC is 42 degrees. Okay, number 2 is a bit more complicated. And again, if you forget or you're not sure, just go to the notes. So number 2 falls into this kind of theorem here, the intersecting chords angle theorem. And it's a little more complicated. Half of the sum of the intercepting arcs is how we find the angle. Well, in the problem we're asking for, we have the angle. So we'll call this, is it gonna right? Yeah, I don't know why it's green. We'll call that X. We don't know its measurement. That's what we're gonna find for now. We can call it X. And we'll plug everything into the proper place of the formula. So it'll look like the angle, which we know is 38 degrees, is 1/2 the sum of the two arcs. One of the arcs is X, the other arc is 18. Now, the way I did it in the last video was that I distributed the half, and we could do that. And then I mentioned at the end, we could have taken out the half or gotten rid of, what am I doing today? Who knows? We could have removed that coefficient here, I guess, by multiplying by its reciprocal, which is just 2. And that'll eliminate, or it becomes a 1, giving me 1 times x plus 18, which is just x plus 18. And here I get, and I don't want to mess myself up, which I will do, 76. And then just subtract the 18, and we're done. We've got that arc we're looking for. And X is, I will definitely mess up subtraction, 58 degrees. Or LO is arc, LO is 58 degrees. Okay, so warm up done. Let's move on to the checkup. 5.6 is the checkup today. Oops, I gotta get rid of that X now. That's why I never use that. Go away. There we go. Okay. So we have some new circle rules. So maybe a good idea to go to the notes. Anytime you see something unfamiliar, let's go to the notes. And today we're going to do we're really only going to do a couple of these, but some of the others have terms that we need to know. So let's read through a little bit. Secant angle theorem. First, let's talk about a secant. That's going to be on the quiz. A secant is a little bit like a chord, except it goes all the way through the circle. Like this segment here, AB, you could call that a chord, but the fact that it goes through and continues on outside the circle, that makes it a secant, not a chord. So again, a secant goes through a circle, intersects the circle at 2 points. So it will extend outside of the circle. That's called a secant. And it says here, what does it say? The measure of an angle whose vertex lies in the exterior of the circle. They're talking about this angle here, angle C. And each of whose sides intersect the circle in 2 points. Those are the two secants. The two sides of that angle are the secants. That angle is equal to half the difference, that means subtract, the difference of the measures of its larger and smaller intercepted arcs. That's the green arc here and the blue arc. So the difference means subtract. You start with the larger one, take away the smaller arc, and then you take half of it. That would get you the angle. So that's going to come into play potentially in our worksheet. The next one, actually this one doesn't, well, yeah, it's a term more than anything. Tangent radius theorem. We're not going to actually see on our worksheet the tangent and the radius connect, but we need to know what tangent means. Tangent is this line outside here, this blue line. We would call that tangent to the circle, and it means that it touches the circle at exactly one spot. That is what makes it tangent. Now, what also is true, if it touches that spot where the radius touches the circle, they are perpendicular. This symbol right here, they are perpendicular. The tangent is perpendicular to the radius if they touch at that same spot. All right, another theorem that we are going to use, tangent chord angle theorem. It says, I'm going kind of fast because you can always pause, you can rewind, read it, listen again. The measure of the tangent chord angle. Okay, look, we have a tangent here, we have a chord here. This angle right there between the tangent and the tangent and the chord, that is half the measure of the arc inside the angle. The arc is in green here. So we take half of the arc and we get that angle created by the tangent and the chord. That one's fairly simple. Tangent angle theorem is the measure of the tangent angle. So now we have two tangent lines. This one's tangent at point A, and this one's tangent at point C. So we have two tangents that are creating an angle that is outside the circle here. The measure of that angle is equal to half the difference, that's subtract again, of the measure of its larger and smaller intercepts. It's very similar to this one, right? We take the difference from the larger and the smaller, and we take half of it. So the fact that they're tangent isn't even any different than the fact that they might be secants. So they're very, very, very similar. It's just that these are tangent lines and these are secant lines. All right, let's try to apply that. What we have here is a tangent line and a chord. So we could go back to our notes and see what does it say. I never start with my pen handy. And I believe it said that this angle, ABC, this angle right here, is half of the arc created from the chord. So angle ABC is half of the arc. I'm going to let you divide by 2. I'm just going to help you set up. You can do that on a calculator. If you can't do it in your head, that's fine. It's the same problem. All 3 of these are the same. I'm going to do 3. You're going to do 2 on your own. What's the measure? We have a tangent and a chord. What's the measure of x, y, z? That's this angle here created by that tangent and the chord. And again, it's going to be half of this. Angle x, y, z is half of 274. You can divide that out. Divide by 2. All right, moving along. I know I go a little fast because you can pause, you can rewind. Now we've got a secant line and a secant line. So we'd go to our notes if we need to. And they're asking us for angle DAE. That's this angle right here, this exterior. That angle is exterior to the circle. It's outside of the circle. So you could check your notes. DAE is half the difference between the larger arc and the smaller arc, 16. Let me make that a little big. All right, I don't want to subtract wrong, I always do. I know it seems silly, but that's my biggest error. So then we subtract. Order of operations says do the parentheses first, and we get half of 42. Angle DAE is half of 42, so angle DAE is 21 degrees. It's just a formula. Plug it in, and you're good to go. Why did I solve that whole thing? Whatever. The next one is exactly the same. All 4 of these are the same. They're all secants with an angle outside. You can barely see it, but there's a little angle out there. I'll just set this one up. Angle DCE, I can't even mark it, it's so small, but it's right there inside, is half the difference of the arc. Start with the larger arc and subtract the smaller arc. Again, PEMDAS says do parentheses first and then divide by 2 or multiply by half. Same thing. I'm going to let you do the calculation there. Okay, and another one is to do with tangent lines. So this is that last rule. We have a tangent and a tangent that creates an angle. They ask what's the measure of x, z, y. That's this angle here. It's very similar to that last one. Angle x, z, y is half the difference of the larger arc, and the smaller arc. A little sloppy there. Super sloppy. All right, there you go. You can subtract, then divide by 2. Again, PEMDAS says parentheses first, divide by 2. That's it. The rest are the same. You are completely ready for the quiz. You're going to ace it, no problem. Have a great day.